Good day everyone, this is Engineer Aljan Michael G. Sabak and I welcome you to our session 4 discussion about Earth science. Last time we have discussed the things about our universe and the Big Bang Theory. And today, we will discuss more on the different underlying theories of the origin of the universe as well as the origins of our solar system. As a recap, we have these two theories under both the conventional paradigm and the Genesis paradigm, the Big Bang Theory and the Creation Theory respectively. The image tells us the differences of both theories with respect to time, as it is known that the Big Bang Theory talks more about millions of years while the Creation Theory talks more on 1,000 of years timeline. Primarily, the Big Bang Theory is the leading explanation about how the universe began. At its simplest, it says that the universe, as we know it, started with a small singularity, then inflated over the next 13.8 billion years to the cosmos that we know today. While the creation is the biblical belief on the formation or creation of the universe written in the biblical context in Genesis 1 verse 1. In the beginning God created the heavens and the earth. Now let's talk more about theory that rivaled the Big Bang. We have the steady state theory. From the term itself, it tells us that the universe is in a steady state. When looking at the image, we can see that the universe is still expanding and there is a continuous creation, but the positions doesn't change a bit. Now, let's try to differentiate this steady state theory from the Big Bang Theory. On the image, we have the two rival models of the origin of the universe, each of which has its own way of interpreting the universe and the processes that it undergoes. First, the Big Bang model, we can see that as the universe is expanding, the dots are moving away from each other. That tells us that the density of galaxies falls as the universe expands. Second, we have the steady state model, and we can see here that the universe is still expanding but there is no change and the galaxies remains on its position while there is a continuous addition of new galaxies throughout. That tells us that the galaxies remains more or less constant as the universe expands and spaces are being filled by new galaxies. The steady-state theory, proposed by Fred Hoyle. It states that new matter would be created as the galaxies moved away from each other and that the universe has always been essentially the same as it is today and that it will continue that way forever. In this model, the universe is roughly the same and uniform at any point in time and space, meaning the universe has no beginning or end in time and from any point. This means that at any instant of time, the universe must look homogeneous all throughout. But eventually, cosmic background radiation in the universe ruled out the steady-state theory and gave the Big Bang Theory the limelight to explain the origin of the universe. Now, let's look to another theory, the inflationary theory. This theory was developed in 1981 by Alan Guth. In this theory, the first moments after Big Bang, the four fundamental forces were joined and resulted to an inflation. It proposes a period of extremely rapid, exponential expansion of the universe prior to the more gradual Big Bang expansion, during which time the energy density of the universe was dominated by a cosmological constant type of vacuum energy that later decayed to produce the matter and radiation that fill the universe today. Or simply, the inflation theory proposes a period of extremely rapid, exponential expansion of the universe during its first few moments, and it was developed around 1980 to explain several puzzles with the standard Big Bang theory, in which the universe expands relatively gradually throughout its history. We also have this so-called oscillating theory. This theory was proposed by Paul Steinhardt in 2001. Simply, this theory means that there is a never-ending cycle from Big Bang to Big Crunch, vice versa. Big Crunch is the terms that's when a universe will come to an end. The theory describes a universe exploding into existence not just once, but repeatedly over time. The cyclic universe theory is a model of cosmic evolution according to which the universe undergoes endless cycles of expansion and cooling, each beginning with a Big Bang and ending in a Big Crunch. The theory is based on three underlying notions. First, the Big Bang is not the beginning of space or time, but rather a moment when gravitational energy and other forms of energy are transformed into new matter and radiation, and a new period of expansion and cooling begins. Second, the bangs have occurred periodically in the past and will continue periodically in the future. Third, the sequence of events that set the large-scale structure of the universe that we observe today took place during a long period of slow contraction before the bang, and the events that will occur over the next 1012 years will set the large-scale structure for the cycle to come. Now, let's move over to the bizarre interpretations by us humans with regards to the origin of the universe. We have these three different theories. The first one is the intelligent design theory, meaning, there is a possibility of aliens or extraterrestrial. This is an offshoot of the creationism theory. Second one is the holographic theory, that means the entire universe is just a hologram and all of it are just experiments. The third one is the multiverse theory, which means that our universe is not the only one, but states that many universes exist parallel to each other. These distinct universes within the multiverse theory are called parallel universes. A variety of different theories lend themselves to a multiverse viewpoint. Parallel universes, on the other hand, is a theory in which our universe is not the only one, but states that many universes exist parallel to each other. Let's have a recap on the things that we have discussed so far before we'll move to the theories of the origins of the solar systems. Here are the different theories of the origin of the universe. You may take time to read it and understand it again. Okay, are you done? Let's move now to the next discussion. Our next topic will be about the origins of the solar system. Let's try to define our own solar system on the next slide. A solar system consists of a collection of objects orbiting one or more central stars. All solar systems start out the same way. They begin in a cloud of gas and dust called a nebula. Nebula are some of the most beautiful objects that have been photographed in space, with vibrant colors from the gases and dust they contain, and brilliant twinkling from the many stars that have formed within them. The gas consists largely of hydrogen and helium, and the dust consists of tiny mineral grains, ice crystals, and organic particles. Historically, there have been two competing classes of hypotheses for the origin of the solar system. These are the dualistic encounter theory and the nebular theory. Dualistic or encounter hypothesis. This theory was started by Leclerc in 1745, then eventually succeeded by Chamberlain in early 20th century with James Jean and Harold Jeffreys. According to this theory, the time when the Sun about to form a large body passing around, it may have drawn some gaseous materials from it. The mass of gaseous materials drawn did not completely escape gravitational pull of the protosun. It continued to spin around it, eventually becoming more dense and gradually formed into planetesimals. And these planetesimals give rise to the planets and their satellites. In short, there is an approaching star that passes to our Sun and then produces tidal bulges to form planets. Nebular theory. It started from the framework of Descartes in 1644, after which proposed by Emanuel Swedenborg in 1734 and succeeded by Immanuel Kant in 1755 and Laplace in 1796. The nebular theory, which explains the formation of the solar system, proposes that the Sun and planets formed from a rotating cloud of interstellar gases, mainly hydrogen and helium, and dust called the solar nebula. As the solar nebula contracted due to gravity, most of the material collected in the center to form the hot protosun. The remaining materials formed a thick, flattened, rotating disk, within which matter gradually cooled and condensed into grains and clumps of icy, rocky material. Repeated collisions resulted in most of the material clumping together into larger and larger chunks that eventually became asteroid-sized objects called planetesimals. Let's try to discern it step by step on the next slide. Here are the images of the events that had happened in the Nebular Theory. First, a supernova ejects matter-rich pressure waves into space. Second, local concentrations of dust coalesce. Rotation of the Sun at the center makes all the materials revolve around it and spin. Lastly, there is a balance between gravity and solar wind, and it continues to spin and creates the planets. Eventually those leftovers are what we called planets, and planetesimals orbit around the Sun. Another visualization of this nebular theory is that of Naruto's Rasen Shuriken. Now let's discuss more on the other theories one by one. Gas cloud theory by Otto Schmidt. This theory states that gas clouds were captured by our Sun due to its gravity, which then mysteriously formed themselves and being drawn to form planets and moons. It means that after the creation of the universe, on the age that the universe is in its cooling phase, which then creates the stars and galaxies, all of the remaining gases and dusts were eventually created and formed into solar systems. Capture theory by Michael Mark Wolfson in 1664. This theory states that it involves the capture of material from a light-diffused star which passed close to the Sun. Meaning, all heavenly bodies were flying around until they are captured by the Sun due to its gravity, and the moons were captured by the planets. Nebular theory. Again, by simple definition, stars are born from a rotating cloud of interstellar gases and dusts. Stellar collision theory by Charles Messier in 1764. This theory is the coming together of two or more heavenly bodies which merges and forms into a larger unit through the forces of gravity. As the name implies, this tells that stars collided and formed planets, moons, comets and other debris. Accretion theory by Otto Schmidt in 1944. Accretion theory, or condensation, or what we call nebular contraction, or dust cloud theory. It says that small chunks of material separately formed themselves into our Earth and the Moon. The planets are then made of space dust and rocks that are compressed and compacted. Meaning all of this materials were slowly clustered together to form planets, and this happens when gaseous material and dust compresses to form an accretion disk. Fission theory by George Darwin in 1984. This is now the discredited hypothesis that an ancient, rapidly spinning Earth expelled a piece of its mass. All things in the solar system comes from the Sun, and it says that our Sun burst one day, and all our planets came from it. Planetary collision theory by William Hartmann and Donald Davis. They say that the Earth was once hit by a giant meteorite, and leftover rocks created by the collision then became the Moon that is orbiting us, and their models suggested that, at the end of the planet formation period, several satellite-sized objects had formed that collided with the planets, thus forming moons and other debris. Alright, now you have known most of the theories with regards with the origin of the universe and our solar system. Let's try to have an activity. Let's go further beyond your own imagination and think. Theories are suppositions intended to explain something based on general principles to justify a course of action. Apparently, anyone is free to propose his/her own theory about anything, both observable and the unseen. Some famous theories are mentioned in the topic. Applying your prior knowledge about astronomy and science, propose and create your own theory about the origin of the solar system or the universe. Write your ideas briefly and concisely, and your proposed hypothesis should have basis. So, I will just leave you with this activity and try to think about the things that could have been possible to happen with respect with the origins of both our universe and the solar system. Next meeting, let's focus more on our dear planet Earth. That's all for this session. Thank you so much for listening. See you next meeting.